即係用 Git 寫嘅。如果冇錯，大家即係冇入錯 theatre 嘅話，咁我哋而家可以交翻啲時間俾小 Lily 開始啦。
OK， 大家好，歡迎嚟聽我講 talk 啦。咁今日呢個 talk 咧就比較特別嚇，因為比較少 talk 咧係會講同動漫有關嘅技術嘅。咁今年都講過2次㗎，一次咧就喺年中Hong Kong Open Source Conference 嗰度講一次啦。然後今個月中咧，啱啱喺 Barcamp 嗰度又講一次，今年嘅第3次啦。咁我個 ID 係 Sololi 啦，咁基本上你用呢個 ID 就揾到我啦。咁今日講嘅 slide 咧就擺咗喺 GitHub 度嘅，建議大家去喺手機啊或者 tablet 度開着個 slide， 咁如果你跟唔上嘅話，咁你自己可以睇翻啦。你揀 slide 嗰陣咧，喺 GitHub 度揾翻條 link 係2018 SITCON 呢個 slide， 咁你就可以睇翻㗎啦。好，咁自我介紹一下先啦。咁我就喺中文大學畢業嘅，就係 Computer Science 嘅 program 啦。咁都畢咗業2年啦，翻嚟都幾開心啊！曾經都喺呢個 lecture hall 度上過 lecture， 喺 lecture 度瞓過覺，亦都喺呢度搞過研討會啊。不過都好多時成日都走堂。曾經我都係中大動漫研嘅幹事啦。咁如果想起我底嘅話，應該都好容易嘅。咁喺我 last year 咧，我就defer 咗1年啦，咁所以最尾1年就冇咩做，咁就去 Our Sky 度做 part time 啦。然後呢段時間咧，我就 create 咗呢一個 enemy 嘅 search engine 啦。咁而家正式畢咗業之後咧，咁我就喺 Developer Hong Kong 做緊 game developer，有時寫下 game， 有時寫下 game engine 咁樣。咁如果想知道多啲關於我嘅嘢，就去 About Me 嗰度睇下。好啦，咁首先講下點解要做呢個 enemy 嘅 search engine 啦。咁曾經做緊幹事嘅時候啦，咁就會經常喺呢個動漫圈子度活躍啦。咁會上好多論壇啊、討論區嗰度咧，咁發現有好多人咧成日貼圖咧都唔俾 source 嘅，然後就走嚟問到底係咩動畫喎？咁實在太煩啦呢啲問題。咁到底有冇方法可以電腦去認到咧？另外就係有呢一集都係 URL 嚟嘅，如果你撳落去咧，你可以睇到更多嗰啲 source 嘅嘢啦。咁其中有啲討論區咧會有啲估動畫嘅遊戲啦。咁好似動漫園都有搞過 OK 啊 All Night 咁樣啦。咁都有啲活動咧係去玩，俾張圖你去估動畫嘅，咁我諗下。呢啲嘢如果要做嘅話，其實咪已經有人做咗咧。咁首先試下最出名 Google Image 啦，search by image 喺 Chrome 度 right click 咁嘛係啦。咁但係好多時都揾唔到個 result 嘅，或者會揾到個 result， 但係佢唔係一啲想要嘅結果啦。另外 TinEye 都係一個好出名嘅 image search engine 啦。咁但係佢好少會 index 到動畫嘅，咁所以9成9都係唔 work 嘅。另外呢2個咧就比較特別，佢係專門係用嚟 search 動漫圖片嘅。IQDB 同埋 SourceNow 啦，2個都 cover 緊好多 Twitter 同埋 Pixiv 嘅一啲動漫圖片啦。仲有好多好多 image board 嘅 website， 佢哋都有 cover 到嘅。咁但係當時嚟講咧，就冇一個 search engine 係專門做動畫嘅，因為佢哋主要 search 咧都係 search 啲同人嘅圖片啊，或者 artwork， 佢哋係想攞一張低清嘅圖揾翻原圖咁嘅高清嘅圖，然後做 wallpaper 噶嘛。咁所以咧佢哋就係咁樣誕生嘅。咁但係動畫咧以前 SourceNow 都冇 cover 嘅，後尾先 cover 翻嘅啫。咁嗰陣時要決定要做呢樣嘢嘅時候，都係查過晒所有 option， 發現係當時未有。咁所以當時就試下諗下可唔可以自己做出嚟咧？咁啊自己上網抄下啦。咁喺 Wiki 嗰度咧 ，image search engine 有一大扎咁樣嘅嘢嘅。我開出嚟睇下。 嗱，咁喺 Wiki 度咧有一大扎商業用嘅 content-based information retrieval 嘅 engine 咧，咁呢一紮都已經係現有做緊 image search 嘅商業 engine 嚟嘅。咁好多咧都唔係一啲我哋可以控制到嘅嘢，即係我哋唔可以擺啲嘢 index 落去，即係我哋都唔可以全權控制佢 index 啲乜嘢嘅。咁然後下面咧就炒就 open source 嘅 project 啦、demo 啊、project 咁樣啦，都有唔少嘅其實。我唔盡錄啦，係啦，咁但係咧睇翻個 license 咧，好多都 close 嘅，即係一係咧你就俾錢啦，一係咧就佢根本冇公開過啦，純粹係有 paper 講過話做咗啲咁嘅嘢啦。咁剩低 open source 嘅都唔少，係啦，但係再 filter 多一個啦，睇下佢 support 嘅功能有啲咩啦。咁其實剩低嘅唔多嘅啫，其中一個係 Lia 啦，仲有呢扎啦。咁但係 private company 呢個都係有啲 concern 嘅，有啲擔心會唔會可能私人控制嘅公司做嘅 project 可能會突然間執咗冇咗啊咁樣啦。咁所以第一個試咧，我已經係試咗 Lia 啦。咁呢個 Lia project 咧係啊，唔係我做嘅呢樣嘢，呢樣嘢係某間大學嘅另一個 professor 做㗎啦。咁我就試下佢做出嚟嘅 project 啦。咁然後咧就做咗。好順利地就做咗我個 search engine what enemy 多啲嘢啦。係而家你 Google 咧，其實 what enemy 咧已經排喺 Google 嘅 search result 度第一行啦。係啊，咁所以你唔記得網址都唔緊要，你喺 Google 度 search 到 what enemy 就得㗎啦。咁入到嚟呢版咧乜都冇嘅，你唔知做啲咩嘅。咁咧，我首先要有張圖啦，咁我求其揾翻一版有張圖㗎啦。咁例如我 copy image。Ctrl V 貼上去，然後 search， 咁就好快就已經揾到個 search result 啦。係啊，再試下其他圖啦。係啊，而家速度係非常之快嘅。係啊，咁你見到啦，佢可以準確到去揾到喺邊一集、邊一分、邊一秒，同埋佢相似度係幾多啦？係咁而家仲有埋個 time code 啦，大約喺成段影片入面嘅邊一個位置啦。係啊，咁就係咁樣啦。咁下面呢隻 search result 咧就係喺啲動畫嘅 database 嗰度抄翻嚟嘅啫。係啊，呢一紮資料咧就唔係我 manage 嘅，係但係個中文譯名咧就我自己補翻落去嘅。係啊，咁好神奇啦，好多人都覺得呢樣嘢係啊，但係點樣 work 嘅咧？有好多人就諗都唔諗就即刻話哇，一定係 AI 啦，一定係 machine learning 啦。但係就好多時諗嗰個問題嘅時候咧，都冇諗過嗰個解決方法係咪最好？係啊，我見過有啲人咧話用1+1都要用 machine learning去做嘅，定係點知得50% 準確率嘅啫？係啊，咁啊呢個時代咧有好多熱門嘅嘢啦，其實係一種好似潮流咁嘅，好似而家講緊 blockchain 咁啦，都係啲潮流嘅嘢啦。咁當然你可以好雀躍咁去嘗試啦。咁但係what enemy佢並沒有用到以上呢幾樣嘢嘅。係啊，佢唔需要做呢啲嘢嘅。係啊，咁澄清翻呢一度先。係啊，咁佢係乜嘢咧？實際上就係頭先講嘅 content-based information retrieval 啦，已經係一個喺 computer science 上面一個幾大嘅 topic 嚟嘅。咁佢都算係一個 computer graphics 嘅 program 啦，即係處理電腦圖像嘅嘢啦。另外某程度上都算係 big data 嘅。係啊，當然就未必話一定要用到咩 Hadoop 啊、Spark 啊嗰啲典型嘅 big data framework 先叫做 big data 啦。咁但係我覺得，如果當一個 system 要去到處理loading 啊、traffic 啊，或者係要解決一啲 performance 嘅問題嘅時候咧，咁其實都已經算係某程度上係 big data 嚟。係啦，咁CBR engine 咧通常咧都會有兩個部分嘅，有一部分就係點樣去將一張圖嘅特徵抽出嚟啦，另一部分就係點樣去 compare 啲特徵嘅。係啦，咁而下面呢一度咧有幾個舉例啦，就係有幾隻 image descriptor 啦、color layout 啦，睇下顏色嘅分佈點樣啦， edge histogram， 睇下張圖嘅邊緣特徵係點樣啦。仲有兩隻我都唔記得咗係咩啦，係啊，仲有好多隻，好似有10幾20隻嘅呢一度，係啦。咁而家嗰個 enemy 就淨係用咗 color layout 啫，咁純粹係因為 hardware 上嘅考慮啦，因為比較快啲同埋唔會咁嘥 storage space， 係啊，所以暫時用咗一隻先。So far 個準確度都 OK 嘅，但係有 limitation 係啊。咁我解釋下 color layout 係點樣運作啦。咁首先呢樣嘢都唔係我發明嘅，呢樣嘢都係一個好 common 嘅 standard 嚟嘅啫。係啊，咁如果你睇翻條 URL 咧，咁佢有一個 wiki 嘅 page 咧，好詳細咁解釋咗佢嗰個 feature extraction 嗰個過程係點樣嘅。咁首先啦，你有張圖啦，然後界成8乘8格啦，咁然後將呢8格入面嘅 color value 攞個平均值，然後咧再將個 color space 轉做 YCBCR。點解要將佢由 RGB 轉做 YCBCR 咧？一般嚟講，人眼對於圖像嘅認知咧，喺亮度方面其實個比重係比較高嘅，係啊，咁所以喺呢個 algorithm 去運行嘅時候咧，佢會喺 Y 嗰邊，即係亮度嗰邊咧係攞個比較大嘅比重啦，然後 CBCR 另外兩隻顏色嗰個比例係比較少嘅，係啊，咁轉咗 color space 之後可以方便我哋去攞呢個 balance。然後做一次 DCT transform， 即係將佢 quantize 出去，例如將啲淺藍色啊、天藍色變做藍色咁樣啦，然後紅色、棗紅色嗰啲變做紅色咁樣啦。然後再做一個 success scanning， 即係打斜咁樣將嗰啲格仔嘅次序由一個 two-dimensional 嘅 space 轉翻做一條咁樣嘅 bit string， 係啊。咁就會呢一個 bit pattern 咧，呢個 string 嘅形式去表達出嚟咧，就會係好似咁樣一紮 hash 咁樣啦。咁呢一個咧就會係呢一張圖嘅 color layout 嘅 fingerprint 啦。由攞住呢個 fingerprint 咧，我哋就可以做更多嘅 image hashing 啦。係啊，咁我哋點樣將呢一個原本係由一個 frame 嘅 image hash 變成一條影片嘅 image hash？ 好簡單，全部 frame 抽晒出嚟啦。係啊，咁首先有條片啦，跟住我就將用 FFmpeg， 有冇人用過 FFmpeg？ 有冇人知道係咩 FFmpeg？非常好，係一個非常之方便嘅 command line tools， 攞嚟做image， 用嚟做 video 啊、audio 啊，或者 multimedia 嘅格式轉換嘅工具嚟嘅。係啊，咁我用 FFmpeg 就抽晒所有 frame 出嚟啦，然後就用 layer 逐個 frame 咁樣去將所有嘅 image hash 上去。都唔算太慢嘅，係啦，然後做一次 deduplication 啦，將啲完全相同嘅指紋抽走咗佢啦，係啦，然後再補翻嗰個時間軸喺個 file 名嗰度啦，之後再 load 入 database， 係啦，咁然後點樣做 compare 咧？咁就好簡單啫，兩段 string 嘅 similarity 就代表咗兩張圖嘅 similarity 啦，因為本身張圖extract 咗出嚟嗰個 fingerprint 已經代表兩張圖啊嘛，係咁兩張圖嘅相似度就即係兩段 string 嘅相似度啦，係啦，咁呢一個好簡單，用 edit distance 就可以計到㗎。好啦，咁但係問題嚟啦，當影片越嚟越多 ，image 越嚟越多嘅時候咧，咁開始 search 嗰個問題咧就變咗係會面對嘅第一個挑戰啦。係啊，咁首先啦，我唔知點解會有3萬幾個鐘頭嘅動畫喺度啦。係啊，咁如果計一計，大約以唔記得12 fps 定24 fps 嚟計咧，有26億個 frame， 即係我有26億條 string 我要處理。有幾多人試過 database 可以裝26億條 record 喺入面㗎？係啊，係啊，咁點樣搞咧？係啊，咁頭先講咗啦，我要 deduplicate 啲相同嘅 hash 啦。咁現時嘅做法咁啱咧，因為 color layout 咧喺呢一個畫面嘅震動方面咧，佢係比較 insensitive 嘅。咁所以佢俾 achieve 到一個比較高嘅 deduplication ratio。係啊，咁可以 cut 咗一大紮重複嘅 frame 嘅。係啊，咁用 running window 嘅方法咧，咁就係去順序啦，由頭開始掃啦，然後見到重複嘅就掉走佢啦，唔重複嘅先留翻喺度，係啦，咁就可以做到一個效果係佢唔會喺兩段 唔同嘅影片，但係相同嘅畫面度掹走咗啲嘢。係佢只會喺同一段影片入面相同嘅畫面，仲要係喺時間上連貫嘅畫面先咁樣走嘅。係因為有時有啲動畫的確係某啲情節係一樣㗎嘛。係啊，咁所以就用 running window 呢個做法係比較可靠。係啦，咁做完 deduplication 之後咧，都仲有8億幾個 image 要 compare 喎，點搞咧？係啦，咁跟住咧就有呢個 LSH， 都唔係我做嘅，好多嘢都唔係我做，好似其實Lyra 嗰個 library 咧頭先 show 過出嚟啦，佢本身已經 support 咗呢一個 locality sensitive hashing 嘅。佢大概嘅概念咧就係、你見到頭先啦，喺上面咧有段 bit pattern 嗰段係 string 啦，嗰個係 feature 啦。下面嗰扎一嚿嗰啲係咩咧？就係嗰啲 hash 嚟㗎啦。咁呢扎 hash 嘅作用咧，就係用嚟加速個搜尋。簡單嚟講咧，就係佢會將頭先 extract 出嚟呢段 string 啦，去抽一啲 sample 出嚟，然後攞咗特徵，例如話特徵 A、特徵 B、有特徵 D、特徵 E 咁樣啦。咁然後當我搜尋嘅時候咧，我唔需要直接成段 string 攞晒出嚟，我淨係需要喺指定我要揾嘅一個範圍，即係例如某個 cluster， 例如 cluster A 嗰度抄咗先，冇嘅話再喺另一個 cluster 抄，係啦，咁樣咧就可以省卻到好多不必要嘅搜尋啦，係啦。咁原本8億幾個 string 要 compare 咧，咁就結果係得100零萬個啫，係啊。咁100萬個 record 嘅 database 大家應該好常見啦，係啊，都唔係太 challenging 啫，係啊，但係都係唔夠快喎，發覺。原本 Lyra 嗰個作者咧，佢個方法咧就係、佢要將頭先講啦，好似 feature A、B、C 咁樣啦，佢會將佢全部 merge 埋一齊 join 咗佢，咁樣之後先再 search 嘅。咁但係我個 approach 比較唔同咧，就係、我會做一個 iterative 嘅 search， 係啊，先 search 部分揾到就停，揾唔到就繼續，係啊。咁由邊一個 feature 開始 search 先咧？咁我就做咗個統計啦。咁呢個表佢打橫嗰邊咧就係佢啲 feature 嘅特徵啦，打棟嗰個咧就係個 population， 即係有幾多個 frame 有呢個特徵，係啊。咁 log scale 嚟嘅呢個，係啊。咁然後我就可以知道到底邊一個特徵係最罕有嘅，係從最罕有嘅特徵開始搜尋，咁樣就可以用最少嘅時間去抽啲 data 出嚟比較啦。係啊，咁嗰邊嗰條 S 型嘅線咧，就係、佢排咗 population 之後咧，係啊，發現係有一大紮嘅 image feature， 底嗰紮咧就係、比較罕有嘅，係啊，佢唔係一個平均分佈嘅 hashing 嚟嘅，係啊，咁所以就可以利用呢個特性咧，令佢個搜尋可以快啲啦。咁當我做完呢樣嘢嘅時候，我已經係差唔多16年頭左右啦。咁去到年中嘅時候咧，咁大約嗰陣時呢個 system 每日有1000零個 user 啦。咁嗰陣時嘅 search time 好奇怪嘅，有陣時好快，有陣時好慢，慢到30幾40秒 HTTP 都 time out 埋嘅。係啊，咁都係唔滿意啦。咁搞咩咧？諗個方法啦 ，cache 起佢，有人用個 Redis 或者聽過 Redis 嘅，係 in memory 嘅 storage。係啊，咁不如睇下。係啊，呢一個就係 Redis 啦，紅色 icon 認住㗎，非常之好用嘅。係啊，佢係一個 in-memory 嘅 database 嚟嘅。係咁，所以 make sure 佢裝住嘅 data 咧都唔會喺 hard disk 度直接攞出嚟，佢會先炒咗 RAM 先，一定會 guarantee 啲係擺喺 RAM 度嘅。係啊，咁所以咧就可以將啲部分嘅 search result 嚟重複嘅 result 先擺咗喺 Redis 度啦，咁然後就可以減輕到 database 嘅負荷。係啊，另外點樣可以再 search 快啲咧？簡單 cut 咁啲咧。點樣 reduce 個 search accuracy 咧？就係見佢抽出嚟嘅 data 可能超過100萬個嘅時候，就 cut off 咗佢啦，剩低嗰啲唔要，掉晒佢。係啊，咁就可以 make sure 到佢唔會太慢啦。咁但係呢一個的確係會令到有啲情況個 search result 係唔準嘅。係啦，另外就要 disable 個 swap， 係啊，swap file 又唔喺 Windows 嗰度會喐嗰個 swap file。 係知唔知 swap file 係咩嚟嘅？係啊，每次一掂到 swap 咧，大家應該都覺得慢啊，即係唔夠 RAM 啊咁樣。咁有時會諗可能swap 去另一隻 SSD 會唔會快啲啊？或者係會唔會可能成 disable 咗 swap 佢咧？其實因為本身 database 其實自己已經有個機制係佢發現 memory run 唔到嘢會擺翻去，佢會撈翻去 hard disk 嗰度㗎啦嘛。係啊，咁如果佢本身又有 swap 嘅話，咪再加多層啦，咁咪令到個架構更加複雜啦。到底我喺以為我嘅 virtual memory 入面嗰度 load data 嘅時候，到底其實喺 RAM 度 load 緊定喺 swap file 度 load 緊咧？係啊，咁發覺我以我經驗咧 ，disable 咗 swap 之後係反而會再快咗。係啊，咁另外就係個 database 嗰扎 data 啦，都換咗由一隻 SATA 嘅 SSD 換咗做 NVMe 嘅 SSD 啦，個效果都幾顯著嘅。係啊，差唔多快咗1倍到啦。係啊，以 throughput 嚟講，係啦，咁呢個時候都仲係有少少問題。係啊，雖然冇以前話 HDD timeout 30秒咁誇張，但係都仍然係有時好快，有時好慢。係啊，呢個時候已經嚟到17年嘅6月啦。係啊，呢個時候已經有2000幾個 user， 因為間唔中有啲人都會 complain 係慢嘅。咁但係都唔掂喎。係啊 ，data 越多點搞咧？係啊 ，we need to be a wall 唔係，一定唔係。係啊，我哋搞 open source 㗎嘛，一定係 open line 㗎嘛。係啊，我哋唔應該將啲 technology 擺喺啲牆後面㗎嘛。係啊，我哋都好討厭牆呢樣嘢㗎嘛，有人中意牆㗎，紅火牆啊，大家都唔中意啦，係啊。咁越嚟越多 data 咧，結果database 成日冧嗰個機會率就越嚟越高啊！好頻繁地，經常又冇反應啊，要 restart 啊，要 reboot 啊，都幾困擾嘅。係啊，咁最後咧忍唔住手咧，就整一部勁嘅 server 翻嚟啦。係啊，以前嗰部咧陰公啊，以前得32 GB RAM 要擺一個100幾 GB 嘅 database 喺入面。係啊，咁所以咧經常會發生一啲你 hit 唔中嗰32 GB RAM，你就要喺 SSD 度抄咧，咁所以就做到嗰個效果就係有時快就喺 RAM 嗰度，有時慢就喺 SSD 嗰度。係啊，個原因就係咁樣嘅。咁所以最直接嘅方法就係加 RAM 咯。係啊，32 GB RAM 唔夠，加到100 GB RAM 啊。係啊，咁而家就已經加到256 GB RAM 啦。係啊，仲有好多 CPU 係啊。係咁依家個 server 唔係當時嘅 server 係快咗嘅，係但都仲有時候係 overload 喎。點搞咧？咁啊研究咗好耐，係啊，發現 Line Solar 咧原來係 single thread 嘅。咁啊理得你有40幾百個核心都好啊，都係一個核心喺度等佢做嘢嘅啫。係啊，咁冇辦法，一定要搞 cluster。咁 Solar 本身咧有 Solar Cloud 嘅 cluster mode 嘅，咁但係呢樣嘢佢又唔係真係 support 得好好喎。佢雖然 support plugin， 但係佢唔 support plugin 嘅 schema。係啊，咁所以結果咧我就自己土炮地將佢分開咗幾個 database 咗啦。係啊，佢叫 Solar Core 啦，即係如果你有用埋 SQL 嘅話，咁即係佢拆開唔同嘅獨立 schema 去做啦，咁就可以令到佢本身 support 嘅 plugin 可以各自運作。係啊，咁我就將一個 database 拆成32個細嘅 database 啦，然後就寫咗少少 program 啦，去將撈入去 database 嘅 image hash 咧，就撈入去最少 record 嗰度。係啊，咁 make sure 佢啲 database 嘅數量係 balance 啦。係啊，然後依家睇下面張圖啦，呢個 search 嘅效果咧，咁就已經見到佢用到好多 CPU 嘅核心。係啊 so far 佢唔係真係一個 cluster 嚟嘅，佢唔係 physically 幾部機啦，佢只不過都係一部機啦，但係佢起碼用得盡所有 core 先。係啦，咁呢度已經幾乎解決晒所有 performance 嘅問題啊。係咁最近 database 已經係差唔多150 GB RAM 啦，琴晚上去 check 過。係啊，咁但係都仲有少少 tuning 嘅 VM Touch 應該好少人聽過啦。呢一個係一個 command line tools 咧，去 make sure 喺 file system 上面嘅一啲 file 咧係 cache 咗喺 memory 嘅，佢仲可以 lock 住咗喺 memory 度 make sure 佢唔會俾人 swap 走嘅。係啊，一般嚟講咧，我諗以你哋嘅諗法咧係一個 program 啦，例如你用 MySQL 啦，咁你會 allocate 100幾 GB RAM 俾個 MySQL 去做佢嘅 caching 啦。咁但係 我睇翻 Solar 嘅 recommendation 咧，佢哋話佢 suppose 咧啲嘢係 cache 喺 system 嘅 file read write I/O 嗰度，係啊，即係 OS level 嘅 I/O cache 嗰度，就唔使 cache 喺 process 度嘅，係啊，咁所以先要用啲特殊嘅 hacking 嘅方法，用 VM touch 咁樣 lock 住個 database。係啊，詳情你可以睇下我個 Twitter 上面啲資料啦。係啊，咁依一個 search time 就非常之穩定啦，0至2秒內已經搞得掂啦。係啊，非常之開心呢個問題終於解決。係啊，另外咧就係呢個大約好似係舊年11、2月左右咧，咁就唔知係咪得閒得滯，咁樣咧就去研究 OpenCV 咧，可唔可以將啲黑邊剪走？因為我發覺喺 search engine 度收翻嚟嘅圖咧，有唔少都有好多人有黑邊。係啦，如果有4:3個 mon 上面度睇一條16:9嘅片啦，或者係一個16:10嘅 mon 度睇條16:9嘅片啊，或者係4:3 mon 上面16:9上面睇4:3嘅片啊，好多黑邊噶嘛。係啊，咁所以就你諗方法去剪走佢。其實本來都 search 到嘅，但係個準確度唔高，係啊，89% 都唔算係合格㗎，都算係 fail 嘅邊緣嚟㗎啦。因為其實好難講一張圖到底佢點先算 exact match，點樣先叫 similar， 係啊，所以掹走咗嚟黑邊之後咧，佢嗰個準確度係90幾%咧，係真係非常之高㗎。好啦，咁呢個咧就係而家嗰個 system 嘅 overview 啦。呢個幾複雜㗎，所以我慢慢逐個講啦。由 MP4 呢度開始，係啊，首先唔知點解有一好大扎嘅動漫影片喺度啦。咁呢一紮影片咧就會自然增生、自然繁殖嘅，係啊。咁當佢發現有新嘅檔案出現嘅時候咧，咁我喺呢一邊咧就有個 file watcher 啦，依家用 Node.js 寫咗嘅。咁一個 process 咧，一個長期 run 住嘅 process 啦。咁佢就會 submit 一個 job 去呢個 RabbitMQ。有冇人知道咩 MQ 㗎？或者 COMQ 啊 ，message Q， 唔知乜 Q 啊？係啊，總之佢就係一個管理 task 或者唔係 task 或者一個好似大運河咁嘅地方啦，人人都可以喺度讀寫嘢嘅。咁大家就其他 process 就可以經過呢個地方去 share 一啲資料啦。咁另外有個 hash worker 啦，咁佢喺呢一個 message Q 入面嗰度發現到有新嘅工作咧，咁就開始做嘢啦。咁就攞條 MP4 影片落嚟度做 image hashing 啦。hash 完之後咧，就將嗰啲已經計好咗嘅 hash 咧，就擺喺一個 file system 度啦。係啊，咁然後就壓縮好咁擺喺度，咁就完啦。完之前咧，佢就會 send 多一個 job 出去啦。咁就會叫個 load worker 咧去 load 翻呢個 hash 入 Solar 呢一個 database 嘅。係啊，咁 indexing 嗰 part 就係咁樣就叫做完成咗啦。係啊，但個 Solar 有時成日會死嘅，但死咗唔緊要，因為啲嘢咧其實已經預先 hash 咗擺喺度㗎。係或者個 database 成個跌咗唔緊要，我只需要喺呢一個 file system 度重新 load 過曬呢紮嘢入去就得㗎啦。係啊，咁 indexing 嗰 part 就係咁啦。然後 searching 嗰 part 咧，咁 HTTP request 喺 Nginx 度嚟啦。係有冇人未聽過 Nginx 㗎 ？Apache 嘅 HTTP server 啦，總之呢一個就係咁喺個 web server 度收咗 request 翻嚟啦，咁就有個 PHP script 去接咗啲 request 啦。係，然後佢就會用翻 REST API 去 call 翻 Solar， 咁做 image hash。image hash 嗰紮魔法就係喺呢度發生㗎。係啊，唔關呢紮 PHP 事嘅。係啊，紮 PHP 係純粹 call 呢一個 REST API 嘅啫。係啊，咁佢收咗紮 result 翻嚟之後咧，咁佢就會有個 ID 啦，有個 file name 啦，時間同埋 similarity 啦。咁然後我就 query 另一個 database， 咁就 join 翻紮動漫 info、analyst info， 即係頭先見左下方嗰一版咁嘅動畫資料啦。係啊，然後就 return 翻嚟啦。係咁呢紮動漫資料點嚟咧？就有另一個唔同步嘅 analyst caller 咧，佢定期去 call 人哋個 database 去抄啲資料翻嚟嘅。係啦，咁另外 Redis 以前係曾經攞嚟 cache search result 啦，而家就已經冇㗎啦。而家因為 Solar 呢一 part 已經好快啦，咁所以唔使再 cache， 但係都仲 keep 住攞嚟做啲 rate limiting 嘅嘢嘅。係啦，咁個 preview 嗰條片係點嚟咧？就係都係會直接 call 翻呢一個原本好大量嘅動 咁佢經呢個 Nginx secure link 咧，就 make sure 話我 return 翻佢嗰條 URL 咧，淨係可以限制到 user 喺嗰一個時段度 cut 條片出嚟睇嘅啫。係啊，佢改嗰個 parameter 咧係會 fail 嘅。係啊，咁當然有啲 security 考慮。係啊 ，open source 頭先講嘅全部系統每一 part 嘅 source code 全部都擺晒喺 GitHub 㗎。係啊，咁所以如果你好奇，你想查下到底發生咩事，或者可能你唔滿意，你想 fork 出嚟改嘅，咁你都可以喺度觀摩一下。係啊，或者你如果發現有啲咩 bug 啊、有問題啊，咁你都可以喺 GitHub 上面嘅 project 上面嗰度開翻個 issue 啦。或者如果你甚至已經知道點樣改嘅話咧，你可以 send pull request 俾我。係啊，咁冇耐之前咧，我都好似有收過 pull request 嘅。咁開下 GitHub 個樣俾大家睇下。呢一個就係有一個 enemy 擺喺 GitHub 上面嗰個 project 啦。係 document 可能有啲 update 嘅。係然後有紮 issue 啦，我未得閒處理啦。係啊 ，pull request 都有收過嘅。係啊，都有人好似唔係幾喜歡我寫嗰啲曲嘅。咁咧，你睇下佢講咗啲咩？你睇下我寫咗啲咩垃圾出嚟？係啊，就係咁樣嘅啫。係啊，咁所以大家如果對於 open source 呢樣嘢話好唔知點樣無從入手，其實好簡單嘅。係啊，有好多人會好介意，可能話你將自己嘅 source code 擺上 GitHub 咧，可能會俾人笑，但係唔緊要嘅。如果你唔擺嘢上 唔擺 source code 上 GitHub 嘅話咧，你可能會錯失咗好多學習機會啦。係啊，咁我都係佢 send 咗呢個 pull request 俾我咧，我先知道原來 PHP 咧都有 template 呢條路。係啊，下面呢一句我都唔記得咗喺邊度抄翻嚟㗎啦。你唔需要好犀利你先開始做嗰樣嘢，但係你唔開始做嘅話咧，你冇辦法變得好犀利。係啊，咁依家我哋都公開晒所有技術上面嘅細節啦，咁所以其實係時候你都可以做翻一個一模一樣嘅 search engine。係啊，以 open source 嘅精神嚟講，你唔喜歡你就 fork 出嚟改。係啊，你喜歡嘅話，你都可以一齊討論。係啊，可以 send pull request 去一齊貢獻。係啊，咁嚟緊嗰 enemy 會做啲咩？唔會做啲咩？咁曾經都有好多人話點解唔 cover 埋動畫啊或者 artwork 啊？咁好簡單嘅原因就係因為 IQDB 同埋 SourceNow 已經 cover 咗啦。係啊，咁所以我冇必要重複咁樣做佢哋嘅嘢，我亦都覺得佢哋做得唔錯。係啊，咁另外都有人提出過話，可唔可以俾個 time code 我，然後我 return 翻一條影片俾佢？呢一個係一定唔會做嘅。係啊，呢個係相當之 risky 嘅一個，或者一個唔係咁可行嘅做法。係因為咁嘅話，咁即係話你要咩片，我咪俾咩片咧。咁我同做翻動畫有咩分別？係啊，咁呢個一定唔會做啦。係啊，同樣地增加 preview 個時間都唔會做啦。係啊，另外就係唔加廣告。係啊，因為廣告嘅收益實在太低啦。係啊，純粹係咁嘅原因啫。係啊，我曾經試過落個Adblock 去調查一下，到底有幾多 user 係裝 Adblock 啦，發現喺 desktop 上面係有90%嘅 user 裝 Adblock 嘅。係啊，咁所以每個月應該都唔夠我搭一次車咁嘅錢嘅。係啊，咁就放棄啦。嚟緊會做啲咩 ？Increase database coverage。係啊，依家都仲有唔少動畫係流感嘅，流緊啲，尤其係歷史悠久嘅動畫啦，同埋一啲未喺 TV 上面放送嘅動畫啦，即係包括係YouTube 上面嘅 promotion video 嗰啲啦。係啊，另外就要掹翻走啲 duplicate。而家 database 上面咧話個100幾 G 咁嘅 database 咧，其實好多係重複嘅，因為我唔知嗰紮動畫其實係點樣增長嘅。係啊，非常之混亂嚇，有啲有720P 啊、1080P 啊，有繁體中文啊，有簡體中文啊，仲有咩？有字幕啊，冇字幕啊，各種各樣嘅版本啦，仲有 Bilibili 嗰啲唔知點樣打到黑晒嘅版本都有嘅。咁呢樣嘢都係嚟緊要處理或者諗方法解決㗎。係 啊，另外要 support multiple image descriptor。一開頭講過，好似有好幾隻 image descriptor。係啦，color layout 當你理解咗佢嗰個原理之後咧，就知道會有啲限制啦。例如話剪咗嘅圖切咁一半嗰啲圖咧，佢都會好難 search 到嘅。咁呢樣嘢就真係要靠唔同嘅 image descriptor 嘅方法去睇下可唔可以增加個 search accuracy 啦。呢個如果陣間有時間可以 demo 下嘅。另外 rebuild front end 好似講咗2年都係咁樣嘅樣。到依家如果你喺手機開咧，個 web page 都係唔 responsive 嘅，好難用嘅。但我都冇心機搞嗰 part。因為我唔係好明啊，如果喺手機嗰度開個 web page，咁我點樣貼張圖落去咧？我要 browse， 跟住唔知撳邊個位，我要另外 save 張圖，非常之唔方便。咁所以喺 mobile 嗰方面咧，反而會可能用 native app 啊，或者係用啲 messenger 嘅 bot 去用係比較好嘅。如果有時間可以再 demo 一下。Move domain 而家用緊 whatenemy.ga 咧係個 free domain 嚟嘅。有冇人用過任何 free domain？Freenom 係啊 ，Freenom 就係一個免費嘅 domain provider 啦。咁佢有一紮免費嘅 domain 可以俾你註冊嘅。咁如果經濟能力有啲問題嘅學生咧，咁你可以考慮下註冊呢啲 domain。係啊 ，top level domain 嚟嘅。係啊，你直接可以 register 一個呢啲咁嘅 domain。咁但係可能有啲 drawback 就係呢啲 domain 可能有機會 renew 唔到啦，或者係 renew 嘅時候可能會變咗要俾錢啦。咁所以長遠地可能都要換一個 domain。係啊，差唔多最後啦。咁如果你中意 whatenemy.ga 嘅話咧，咁就share 下支持下啦。咁另外有 bug 發現到嘅話，喺 GitHub 啊或者 Telegram、Discord 嗰度揾我啦。另外就係 support 有2個方法嘅，有一個咧就係 Patreon 啦 ，Patreon 就係Patreon 就係一個 monthly 嘅 subscription 嚟嘅，佢定期每個月1蚊、5蚊、10蚊咁樣去俾嘅。如果你唔 prefer Patreon 嘅話咧，你用 PayPal 都得嘅，一炮過。呢個就係 Patreon 嘅 page 啦。咁而家呢啲收入都係完全係靠 donation 去支撐伺服器嘅電力同網絡成本嘅。勉強都夠嘅。但係就 expand 唔到。即係已經買唔起 hardware 㗎啦，以呢個數量嚟講。但係電力上係冇問題嘅。另外我哋就有 Discord channel 啦、Telegram channel、Facebook page 差唔多荒廢咗。Google Plus 嗰邊都係。依家最活躍係 Discord channel， 有好似差唔多成1000人喺入面嘅，主要都係英文為主啦，但係都好似有啲中國人喺入面。如果參與討論嘅話，join Discord 嗰啲啦。Telegram channel 主要係我睇下開唔開到。呢一個咧就係 database 嘅 update 啦，或者可能 database 有陣時冧咗啊 server restart 啊，啲資料都喺呢度發布啦。最後 credit 當然要多謝呢個 Lion project 啦，因為基本上成個 whatenemy 嘅 project 咧都係基於呢一個 Lion project 同埋 Lion Solar。Lion Solar 係 Lion project 嘅一個 solar extension， 去將佢 integrate 入去呢一個 database 嘅。咁冇咗佢嘅話，呢個 project 冇可能成。令 AnyList Info 亦都幫我填咗好多嗰啲動畫嘅資料啦。佢有提供 AnyList API 嘅。以前係 REST API 嚟嘅，而家轉咗 GraphQL 啦。咁好似啱啱頭先，如果你哋有聽過 GraphQL， 咁你可以參考一下、觀摩下，試下玩下。另外要多謝好多位 Patron 啦，咁其中 B 殘曾經都係中大 CS 嘅學生嚟嘅。都係我哋啲同學嚟。咁佢由好早開始已經開始 support 呢一個 project 㗎啦，都已經超過2年。另外就係要多謝好多唔同嘅人啦，去幫 whatenemy 去 integrate 去唔同嘅 extension 啦。咁 4chanX 有個 browser extension 啦，係 4chan 呢個 forum 嘅一個 web extension 啦。咁依家佢哋可以喺個 extension 度就咁撳個掣就飛張圖過嚟 search 㗎啦。呢個都已經差唔多2年前已經做落咗㗎啦。另外下面呢個都係啦，三萬紅就係 Source Now 個作者啦，佢個 website 而家都有條 link 咧喺佢個 website 嗰度將啲揾唔到嘅 result 再寫翻俾我嘅。係啊，另外呢個係 VUE 嘅大神啦。如果你有上 GitHub 嘅話，你 search 啲 ID 咧，發現有100幾200個 project， 全部都係講 VUE 嘅。係啊，咁佢有其中一個 project 咧就係 Document 啦，咁就係將 Markdown 變成一個 web 版嘅 API document 啦。另外就係有人曾經 report 過個 XSS issue， 有冇人見過 CV 字頭啊？係咪見到都驚？cross-site scripting 啊，竟然賴嘢啊！係啊，我都冇諗過咧，有一日我會擺 source code 上 GitHub 咧，係會有人 report 翻呢啲嘢俾我知。其實大部分人喺 open source community 咧都係 good guy 嚟嘅，都係好人嚟嘅。好少人會真係咁黑心去攻擊人。多數都會係好善意地提醒你啊，你又將個 password commit 咗上去啊，delete 翻去啊，啲 token 啊啲咁嘅嘢。所以唔需要太擔心喺 open source community 度你會遇到好多心懷不軌嘅人啦，應該就唔會嘅。多數都係好人嚟嘅。咁啊 report 咗 issue fix 咗啦，唔使擔心嚇。咁然後仲要多謝好多喺 Discord 上面嘅 fans 幫我解答問題啦。因為曾經我都經常會收到好多人直接走嚟問我關於呢個 project 嘅嘢，我都答唔晒咁多嘅。咁依家有其他人幫我手就太好啦。咁另外就係要多謝任何一個曾經 share 過啊、投訴過啊、分享過或者俾個意見呢一個 project 嘅人啦。另外最後就要多謝任何一個總之為呢個世界帶嚟動畫嘅人啦。多謝大家。呢個就係我 Twitter account 啦，我喺 Twitter 同埋 Telegram 上面都幾活躍嘅。咁如果你想揾我揾得最直接嘅方法咧，就係呢兩個渠道啦。另外仲有我 Instagram 啦。我哋啲新一代你唔玩 Facebook 噶嘛，我玩 Instagram 啊。咁另外就係呢度有一紮我喺 GitHub 度抄到好多 open source project 係關於動畫嘅。咁如果你有興趣嘅話，咁你都可以睇下啦。再仲有幾多位係仲讀緊書㗎？未畢業嘅，都唔少。如果你哋可能遲啲要做final year project 嘅話咧，你哋不妨可以睇一睇呢一紮好多嘅呢度，關於動畫嘅一啲 project 技術啦，非常之多。Image processing，好多 AI 啊、machine learning 嘢喺度嘅。咁如果你諗唔到做咩 topic 或者冇咩 idea， 唔知做咩 project 好嘅話，咁你可以喺呢度抄下啦。而家有啲咩問題可以而家問？如果太怕醜唔想問嘅話，可以私底下揾我問。如果冇問題嘅話咧，我仲可以 show 多啲其他嘅嘢俾你睇嘅。大家想問問題，我即刻 show 多啲嘢俾你睇。冇問題嘅話，咁我繼續講嗰度。好啦，頭先呢個 slide 呢個 project 上面咧有好幾年嘅 slide 啦，咁其實已經係06年 present， 每年一次啦，大約。06年 present 到而家嘅，咁如果你睇完 SITCON 呢個 present 嘅 slide 之後，發現仲有啲嘢唔明，你可以先睇咗舊嗰啲 slide 先。呢一度有每年嘅 project update 啦，咁其中07年呢個 slide 咧，就係講過呢一個唔同嘅 image hash algorithm。咁呢一集左上角第一張咧，就係我用嚟 search 嘅 image 啦。然後打洞睇落去咧，就係同一條 search algorithm 嘅。最左嗰洞就係 color layout， 隔離嗰洞係 edge histogram。然後再每一洞好似係咩 JC 啊、咩 opponent histogram 啊、FCTH FCTH 啊、JCD， 有一大紮我都唔記得咗咩名嘅 algorithm 啦。咁你發現咧，其中有啲 algorithm 咧係完全唔 match 係好似中間有一棟啦，唔知點解出大家認唔認到呢個 channel？係啊，咁中間有一棟咧，完全係 search 緊另一樣嘢嘅，咁我就可以一眼就睇到到底有咩 search algorithm 係適合攞嚟做 searching 啦。係好似第二棟咧 edge histogram， 簡單講一句啦，就係佢淨係睇張圖嘅 edge， 佢唔睇顏色。係啊，以佢嘅 algorithm 嚟講咧，係第一步 hash 個 image 嘅時候咧，佢已經係轉咗做黑白㗎啦，咁已經掹走晒所有 colour 嘅 information 嘅。咁所以你見咧好快咁就掃落去咧，佢其他 search result 以 similarity 嚟講咧，最頂嗰個咧就係最相似啦，最底嗰個就係冇咁相似啦。咁已經見到佢呢個 algorithm 喺 accuracy 方面唔係咁好啦。另一個玩法咧就係我可以試下 search 唔同嘅 algorithm， 然後 combine result cross check 到底佢係咪同一張圖啦。咁呢樣嘢都有辦法可以 increase 到 accuracy 嘅。咁但係需要 hardware cost 可能就係講緊 double 或者 triple， 如果多一隻嘅話就已經 double 啦。咁所以長遠我要研究度一度條數，到底 server support 到呢樣嘢。關於頭先講啦 ，WhatEnemy 而家提供緊嘅有幾個 API 啦，而家 API 大約好似有百幾個 token 係 send 咗出去嘅，係啊，咁佢哋developer 攞住個 API token 咧，佢哋可以 develop 自己嘅 WhatEnemy 嘅 app 啦。咁喺 Play Store 上面你 search WhatEnemy 已經揾到兩個啦，唔係呢個啊，中間呢一個唔係嘅，係啊，咁呢個唔知好似撩鼻屎咁樣講咧。咁係一個我唔識嘅 developer 啦，走嚟問我攞 API token， 咁跟住佢自己寫咗個 Android 嚟嘅。另外呢一個啦，好似都係內地人寫㗎啦，係啊，都有用過都 work 嘅。但係 so far 好似未有 App Store， 未有 iOS 嘅，係啊，唔知點解，可能過唔到審查。另外曾經 develop 過 Facebook 嘅。喺好早好早之前已經 develop 過㗎啦，但係 Facebook 好似都係冇 approve 過，係啊，我申請咗好幾次都冇 approve 到。其實關於呢個 project 咧，曾經都有諗過好多想法嘅。其實呢個 project 可以慢慢 extend 到好似做到 YouTube 嘅 content ID 咁樣啦，去幫 website 去自動偵測會唔會有啲有機會侵犯版權嘅物品上載咗上去啦。係啊，另外就係可以做 auto tagger 啦，即係例如咧集影片全部 rename 曬做1、2、3、4、5，或者 new file 括弧1、new file 括弧2、new file 括弧3咁樣啦，全部變咗做呢啲檔名嘅時候，你想揾翻佢原本係邊套動畫邊集嘅話咧，咁呢個 system 其實係可以做到呢樣嘢嘅，但 so far 未有 application 真係做咯。另外大家留意下WhatEnemy 咧係 FAQ 個版咧有個更加詳盡嘅解釋啦，到底點解有陣時啲 search result 會 search 到，有陣時 search 唔到。係啊，大家揀翻 FAQ 個版就會見到有好多資料可以睇㗎。係啊，另外呢一個好特別嘅發現咧，畫出嚟嘅圖其實都 search 到嘅，唔試下。齋畫嘅，睇兩睇先。哇得啊！咁最後咧就因為見到 SITCON 都係以學生為主嘅一個 conference 啦，咁呢一度其實無論你係學生又好定出嚟做嘢都好啦，咁其實呢一個 repository 我覺得係一個明燈嚟嘅， 大家有冇睇過呢個 repository GitHub 上面 Developer Roadmap Chinese 係啊，咁呢一度咧就好完整咁樣講咗你點樣由一個 beginner 啦，最終一路做到front-end developer、back-end、full stack、DevOps 咁樣嘅一個 roadmap 咁嘅嘢啦。咁中間有介紹好多唔同嘅技術嘅，咁嘅 SSH 啊、GitHub 啊，然後建議大家 start 咗呢個 repository 去睇下自己有啲乜嘢需要學或者準備要學啦，特別 highlight 咗嗰啲啦。非常之完整，我唔詳盡講呢一度啦。咁但係如果你好迷茫，唔知要學啲乜嘢，或者唔知而家點樣先至可以成為到一流嘅 developer 嘅話咧，咁我建議你起碼你要識晒呢一度所有嘢。你唔需要識晒嘅，起碼知道呢一度講緊嘅所有嘢係乜嘢先。係啊，咁你先至可以成為到一流嘅 developer。係啊，咁如果仲讀緊書或者啱啱出嚟工作嘅你，大家就要加油啦。係啊，多謝大家。
only on the software aspect. So for further introduction, I'll pass the time to David.
So I've already been introduced, so quickly, Landsville Technology is listed here. That's the company where I'm the CEO and founder of. We're originally a Shenzhen startup, but we now are located in Hong Kong and use equipment here, for instance, the unused RCL maybe very soon, and the HKUST lab. So just a little explanation, so not that someone thinks I'm making a subversive advertisement. No, I'm actually the CEO of Landsville, and it's a really small startup. So what do we do in LibreSilicon? We make truly free silicon by introducing a new manufacturing process, the LibreSilicon process. And the idea of that is that it's distributable over multiple factories. And we also evaluate ways to make this process work with as few machines as possible, so that you also could build that stuff in your basement. So we introduce a new license, the LibreSilicon public license, because the GPL and the BSD license do not apply to anything below beyond the RTL gate level implementation, and really everything beyond that, like the layout and the IP costs, are not covered by the free licenses. So manufacturers don't have to care at all under which license your IP costs are, because they don't apply to IP costs in license. And that we're gonna change with the LSPL, which uses special legal quirks, usually used to protect company intellectual property rights, and we give these rights to a foundation, and that's some kind of a legal hack to extend the GPL to silicon. And all the IP cores we develop are on GitHub, so there is no NDAs. If you want to make your chip, you just make a Git clone. They go further into details, and the last thing is no NSA snooping hardware backdoors like this God mode risk in Intel CPUs, because everything can be publicly, by the many-eyed principle, be reviewed. And if there is a backdoor, some secret undocumented risk core, it won't stay long in the layout, because everyone sees this core and it's being discussed and removed. And the guy who introduced this patch will be under a lot of scrutiny. So why are we doing this? MPWs, that's multi-project wafers, cost around $20,000 and you wait up to a year until you get your prototype. So that they also can, without any previous notice, just throw you out of the MPW multi-project wafer shuttle, run it at any volume. And you never see the full layout, because you don't even get the GDS2 files. That's the files which contain the transistors, the actual guts of your logic. You never see that. Not even after signing free NDAs. You never actually see your full-blown chip in your computer. And that stuff is totally manufacturer dependent. So A, you never get your layout. B, they never deliver you the masks, the optolithographic masks to actually make the etching steps during production. And it wouldn't help you anyway, because it's specific to this factory with their proprietary manufacturing process. And however, because you have to use manufacturer-specific IP cores, your Verilog code will be manufacturer-specific too, and so it will be covered under the NDAs of the manufacturer, and that means you can't even publish your own designs. Your Verilog code will be retroactively also protected by the NDA of the manufacturer. So you can be sued if you push your own Verilog code to GitHub. That's unacceptable, this situation. So imagine you like to manufacture your own chip. You go into a foundry. Sign at least 3 NDAs. Invest up to $1 million until you have your mask sets so far and everything and your prototype works. And then comes Mankhut, or a tsunami, or an earthquake, and you have to change the factory. Well, you're fucked. Why? The technology is completely different. So, like, they have totally different, with the auto factory, totally different standard cells, everything, except maybe if you're lucky, if you're very lucky, you also have bought the standard cells from Synopsys. Then you have a chance to just, send them your placed and routed GDS file, and they put everything together and make you new masks. But you still have to pay the new mask set for the new foundry. Because though the foundry won't give you the mask set. Okay, well, after a typhoon, a tsunami, or an earthquake, these mask sets will anyway be shattered, maybe. But anyway. And but the key point is you have to invest all the money you had to invest for the last foundry all over again. So a natural disaster, and it costs you like $2 million. You don't live in that region, but the factory, which was there or is still there partially, was there. And so you have to move and you have to reinvest this many $1 million again. You just burn money. You can also take a few $1,000 Hong Kong dollar bills and roll a joint with it. It's the same thing. And you see, a lot of companies don't have the nerve for that. So in the last years, the new designs have decreased steadily. So it hinders innovation in this situation. It's a nightmare right now. And we need a new standard. We need a standard for manufacturing. And that's what we do. We introduce an open source chip manufacturing process standard specification. That means we specify exactly steps to get to a certain result, to certain parameters of our test wafer. It's a Pearl River 1. We also introduce a fully integrated EDA. Actually, most of the commits are from me. If you know C++ and Qt, feel free to make Git commits. And we rent the clean room at HKUST, where we do etching and doping and do some research on the best geometric structures for FET, field effect transistors. So the Qt EDA, as I mentioned, C++, Qt5, Python Qt. We intend to introduce Clash. That's Haskell-based formal language to describe hardware. Giselle is also, it's not on there, but Giselle is also on our wish list for Qtflow. In the back end, right now, we use Icarus Verilog for simulation. That will most likely stay this way. QRoute and Graywolf will be, in a furthest point, totally replaced by LibreSilicon compiler. LibreSilicon compiler is written in Haskell, so if someone of you likes functional programming languages, the LibreSilicon compiler is certainly something we should look into. It goes from the lib file to a hierarchical place and route. So give him the lib file, if there are these hierarchical parts, it does inlining and xlining, and this way it increases the performance of the place and route, because it makes blocks which it places and routes, and these again get placed and routed. I draw quickly how this very simplistic core looks like after the LSC treated it, and then I explain. so okay, something like that. So you have like a power rings, and then it goes and looks for reoccurring IP cores and routes them, and then it places and routes them, and then it puts it into the higher hierarchy inside the path frame based on the pin assignment from the path frame generator. A lot of terms you maybe don't know if you're not into chip design. So we have a path frame generator that's kind of, you say, I want so many, I want a frame around the chip. That's where you put the wires at. You basically press a gold ball with a gold wire onto these pads that around. That's what this ball and this wire means up there. And that's a pad cell. And so out of these pad cells, you make a so-called pad frame that surrounds the actual logic. And then you need a pin assignment. You need to say how many pad cells do I want, what type of pad cells, and what pins inside my logic go to which pad cell. That's that. And that's LSC, just a quick detour. And that increases the routing, placing and routing extremely compared to Grey Wolf and Q router, because Q router and Grey Wolf did just flatten everything out, and then you had a billion logic cells which you had to place and route individually. And with LSC, we actually don't do work twice. We look for reoccurring net list structures, X-line them, place and route them, make an IP core, IP block out of it, and place and route them. So we basically reduce the CPU time to place and route extremely. But LSC is still in progress, and the guy doing this also works for a crypto company on the side, so we will see. So if you wish, if you feel happy, if you like functional programming languages, just look at LibreSilicon compiler. Here's the footnote. It's false hardware, Andreas Westerbeck. Feel free, he's happy about Git pull requests. Yeah. So yeah, again, little collection of helpful links if you want to help us. So the Pearl River, that's our test wafer. So what's up with the test wafer? So the test wafer contains all kinds of structures of which you need the parameters in order to design your own layouts. Like for instance, an analog digital converter or a pad cell. You need the values from the Pearl River. So we measure that out at HKUST. Then we go over to RCL, set the process up, kind of thumb over middle finger times P. Then we go measure and tweak the parameters of the machines until we get the values kind of like the ones from HKUST. And we repeat it, for instance, in Russia, in India, in Shenzhen, in Shanghai. And then all the factories can spit out the exact same results or similar results. So if you have these pad cells from GitHub, you can either manufacture them in Shanghai, in Shenzhen, in India, in Russia, or here in Hong Kong directly. So that's the idea of the test wafer. So that's a picture of the Pearl River. You can see you have all these little yellow squares, that's test pads, where we go on with test probes and measure out the values of our test structures, like the resistance of the polyresistor, the resistance of poly with silicide. You can Google it if you're interested in silicide formation. It reduces the resistance, that's why we have to measure poly twice. Polysilicon, to explain a little bit, and I know I'm a little bit deep in this topic. Polysilicon is a very granulated silicon, and it's usually used in very low, high resolutions CMOS processes to self-align the implant of the junction. So let me draw a MOSFET so that you understand. Thanks. How do I? now I get here. Now my voice is louder. Wow, cool. How to? Okay. Do you still hear me? Yeah. Okay. Let's see. Blue, green. Okay. Let's say we have actually our process is a twin well process with STI, so shallow trench isolation. But for simplicity, I let go of the isolation details. So let's say we have here an end well. Can someone not see that clearly? Hands up, please. Everyone sees that? Who sees that clearly? Let's do it in the Excel. Okay, something is broken in the CPU. Who sees that clearly? Hands up. Okay, very good. If it goes to there is a trouble. So now green. That's the bulk. And now we have here a polysilicon. Let's say bulk is shallow and it's more end than the end well. That's a bulk. Very simplified. Then we put on here, we put the polysilicon gate with gate oxide. And then we have here actually openings. That's oxide. That. And now we don't want to have too much overlap between the P plus junction and the gate. And that's why we use polysilicon, because now we can implant here. And what we get is here this polysilicon absorbs the implantation underneath. So we get nice junctions which are nicely aligned. Polysilicon is a type of silicon which is very granulated, so depending on the heat and the recipe, the granulation, the resistance, and the leakage of this shadow varies, and that's something you have to test out in the lab. And we have to measure that out here. So we have to measure out the resistance versus the shadow leakage and so on in the lab. And we also have to find out what the okay, we know the difference kind of, it's like factor 10 of resistance of polyside versus normal polysilicon, but we have to find things like that out. And that's one of these test structures we put in there. Here we have something really awesome, a Hagen over there. Hagen, that's Hagen. He did this beautiful piece of layouting. It's beautiful. That's our bonding pad here. And the cool thing about that is, usually you have a real stress. You have, you have to imagine that's a gold ball, that's a gold wire. Okay, so normal contact pads are aluminum, and aluminum, I don't know whether you know it, in airplanes, mercury is prohibited. You're not allowed to bring mercury onto an airplane because mercury dissolves the oxide layer on top of aluminum, which immediately builds the way up when it touches air, oxide. But then there is new elementary aluminum when the mercury dissolves the oxide. And then it oxidizes and it gets dissolved. And so if you drop mercury in an airplane, the mercury eats itself through the airplane falls apart and you fall. So that's why mercury is not allowed in an airplane. And these soldering balls here are usually brought onto aluminum pads with ultrasonic solder, which actually sweats out the oxide beneath the ball, and so it attaches to the elementary aluminum. So we, however, do something different. On every aluminum layer, because we have to walk around with the wafer in the lab and we don't want to have oxide interface, we put a little ultra tiny thin layer of titanium on top of the aluminum. A little bit technical stuff so that you don't go out and just... I talked about how terrible the politics of semiconductor manufacturing is. That's technical details. What we do, we add a little bit titanium onto the aluminum, so that the wires don't oxidize while we walk around with it in the lab. It's always protected instead of the oxide. In the same vacuum, we sputter 600 nanometers of aluminum, we sputter like 10, 20 nanometers of titanium, then we etch everything with hydrogen peroxide, no problem with oxidation. Awesome. So, next thing, that thing is pad frame here. So top layer is aluminum covered with a little bit titanium, and then where's my cursor? Here's my mouse. However, because go a little bit into detail. So this is nice. So what we have here is so we have these metal layers, right? And then we have contact throughs. That's different via types. That means from a point of how they're interconnected, we have different metal layers. Here we have one metal layer. That's aluminum here covered with titanium. Here it goes down to the oxide, through the oxide. And here is oxide. That's really nice what we did here. And then another one. I don't know how many of you actually study electrical engineering. I think maybe you must think, oh no, not another electrical engineering lecture. I can't help. Sorry. Then we have here again oxide. So, and that expands into this direction. So it absorbs the stress while bonding. So actually, we estimate, but that's something we have to test in the lab, whether we can put transistors directly under the bonding pads without damaging them and putting solder balls with ultrasonic soldering on top. If that works, we can actually have squares, because usually they're like the Moses pad frames look kind of like this. You have here the soldering pad, the bonding pad, and then here a wire, and then here a lot of stuff, which is secret for some releases, synopsis releases, and then here the pin which goes to your logic inside. And that makes, if we can make squares, we can shrink the dies. We can put more chips onto one wafer. That means, by the way, you can pay with Bitcoin for a prototype. So, like, more Bitcoins on my wallet. But yeah, that's basically it. So that's really beautiful. That's different metal layers, and they are next to each other. So that looks in practice like this. That the stress usually goes down, it isn't directly forwarded by this via. Basically the titanium and the aluminum are a little bit both, but downstairs there is LTO, that's a really fluffy glass. It's like glass foam. LTO is like 5 times low temperature oxide, it's 5 times less dense than thermal oxide. That means it's basically like a pillow. So basically all the stress is feathered like a pillow, like a mattress. So it's very possible that below here we won't have any stress anymore onto that MOSFETs. So we might be able to put the driver stages directly under the pad. But yeah, that's come on. So that's a little bit explanation. And that's of course because I'm a Discordian, so of course Callisti has to go the golden apple. Only upload divine code Discord. Yep, I put it in there. That's the picture to show that we even can etch pictures. So you can convert a PNG that's actually originally been a PNG into magic, into GDS, and etch it onto your chip. So if you have some cool messages or company logo, you can actually etch it onto your layout. So yeah. So and that's the Qflow EDA. So that's from the other side. I still have some bugs. You see the terrible big pad frames, pad frame cells up there, with this contact here. And I have a bug in the magic rendering. So the left and right cells are the wrong way around. I think I fixed that since I made the screenshot. Anyway, so that's these, and they make your chips very big. And big chips means less chips per wafer. Less chips per wafer means making a chip is more expensive. So square pad cells, driver cells are much better, more cost efficient. So yeah, if you know about semiconductor manufacturing, please help. So everything is on GitHub. You can look up this, and the slides are on GitHub. They're in LaTeX. So there is a PDF and slides and everything. Help. If you know about chip manufacturing, anything, electrical engineering, if you can't see any circuit boards after you come home after your lecture, please help us, right? We really need people who like engineering. And when you fit with licensing, help us with the LSPL. If you know some legal stuff about free licenses, please help us. And you can also help in other places like with the EDA and so on. Our to-do, we want to shrink the Pearl River even further to get better measurement value set, to provide to the manufacturers to introduce our process. We need to really review the masks before we physically produce them. Is someone of you HKUST student? No one. Okay. Or maybe everyone has fallen asleep because it got too technical. It also might be possible. We have to document the measurements, and I have to update the documentation of the process. That's certainly to do. Hagen wants to make the simulation, the basing parameters. We will, refine the process, and hopefully mid of next year we will have the SITCON the North Point MCU. Number one, that's like pin compatible with the Atmega from Arduino. Arduino, the board every one of the awesome hacker tinkers with it and feels cool that he knows how to copy example scripts into Java-based editor. This thing, this North Point MCU will be Bing compatible, but the whole layout is on GitHub. So that's planned for the mid of next year, and we already have some potentially big players interested. I suck as a CEO, I can't keep secrets, but now it's a talk, so I just say there are some people who are interested into what comes out of the North Point. So stay tuned, we're really working hard on satisfying the interest. Yeah, license, that's also something, that's also a to-do. We have to finalize the license. We looked at the CERN open hardware license, which is not completely suited for our purposes because it doesn't cover like special structures like what I've shown you, this bonding pad. So we introduced the special license, we still work on the special license together with my friend, his lawyer, and hopefully we get it done before we have final standard cell library. The idea is to link it to some certain attributes and basically protect the standard cell library. So when you silicon verify the IP core with LibreSilicon, it's silicon verified with LibreSilicon, and the lib you use to do so is protected on IP protection. So it's intellectual property, belongs to a foundation in Berlin, and they will basically fulfill the role of a company if someone else violates your intellectual rights in this IP core and sue the company. So, that's basically how it works. But as long as everyone behaves nicely and honors the spirit of free and open source hardware and software, the foundation won't do anything. So I'm close to done, I guess. I'm so transferable. So as I mentioned before, we want to have a design which can be built in many places like Shanghai, Shenzhen, India, Hong Kong, Russia. And we want to also provide it to universities. Also to universities which don't have as much funding as the government claims, like and they only have this half setup lab, but at least have a furnace already, so they can make their implementations with this furnace. So they also can start using LibreSilicon to make chips even if the setup is the half setup. So if they only have a furnace, we want to make it possible that they still can make CMOS projects. And for that, as I mentioned before, we need the North Point, the Perl level to get the parameters so they can set up their furnace-only ultra low-tech process. So the history so far. So I got the lab, HKUST. You already saw pictures. I gave a talk which was a little bit shorter, much shorter at the Congress. That was in 2017, and I got some cash to fund the whole venture. Then now we developed the first version of our LibreSilicon process, which still needs some cleaning up to do by me. We had a hackathon called Toolchain. I got a t-shirt here. We right now lay out the first test wave. We finished the test wave and do tests. It's like tandem. We now have an office over in Sengmanshu, so we hang there and harmonize the layouting, and I check whether it's working with our process, how it recently is, and so on. And of course, we have to really take care about what magic, the recent tool we use, because Qt is still buggy. What magic spits out so that the mask set actually makes sense when you send it into manufacturing. So again, the links, it's a little bit chaos. So we have the process. Feel free to review it, look over it, criticize it, send me an email, come to Chenglan Street and get some coffee from the kitchen and talk with me in person about process details and what you don't think is not right. Or you can look over Hagen's layouts of the call level. Oh, there is H is too much. Anyway, it's not the HHTTP, it's not the hyper transfer protocol. The text there is the text transfer protocol. There is H too much on the process. Anyway, happened tonight at 2 a.m. And the standard cell library, also Hagen, chipwatch Hagen over there. And of course my CUHK Leviathan or Leviathan CH, so for Switzerland, because Leviathan was already taken. Yes, we have some community projects. So Yosis, that's Clifford. He actually knows what we're doing. We are emailing, he's on our mailing list. Icarus Verilog, I sent him an email, he never replied, the guy, but Hagen knows him, so kind of. So maybe at some point he will notice that we use this tool to actually simulate physical chips. And we have open circuit design, that's Tim Edwards, and he also is on our mailing list. Then we have the Hong Kong University, NFab Lab, that's where we do the prototyping. eFab Labs, that's Fabless Foundry somewhere in the United States. They're like a startup and distributed all over the place. And Tim is working for that company, and they're already waiting desperately for our process. And we have the Landfill Technologies, that's of course my company. It's actually my family name, translated with a nice Chinese calligraphy, directly from German to Chinese. That's the logo. Not to Landfill. No. So now the conclusion, and then we're done. And I think, yeah, I'm overdue. Oh no, 15 minutes left. Weekly, so we have a Mumble conference every Sunday, 9 p.m. Hong Kong time. That was the best time we could find, because all the people who work in the office, they have a day job. At least on Sunday, they're at home, usually. And yeah, that's Mumble, that's down here is the link, where you can download Mumble if you want to join. But I can also come just visit. I mean, we have 4 bus stations from HKUST, so just come by if you're here in Hong Kong. Right? Otherwise, here we have this server, it's standing in Germany. If you look it up, Frankfurt to be more precise. No, Karlsruhe, no, in Karlsruhe. Yeah, and how can you contact me directly? So I don't like talking on phones. So I didn't even include my phone number. Also, it's a stream, so afterwards I get even more spam calls than before. So I omitted my phone number, but you can send me an email. Then you can check out whether I'm on Mumble. So I'm sometimes hanging out on Mumble because I'm bored. You can check out. Careful, there are sometimes strange people there because it's a public server. It's like IRC, just a voice chat. Or you can directly come to IRC. I'm usually, like always, my IRC client starts always when I start my office computer. I'm hanging around on Freenode as Leviathan CH because, again, Leviathan was already taken. I also have a blog, the Leviathan.ch. So. And yeah, thanks very much. Are there any questions, or is everyone already followed us? No, the eyes look open, but I've already noticed there are people in the MTR here who sleep before night. Oh, the guy lost. This person. Hi. Any questions? And any questions about the project or how to help, or anyone who does. Everyone understood the talk, right? So I hope. So then, yeah, I'm actually done. I mean, that's a lucky cat, and thanks very much in training in English. So I'm through. I could go through the layouts for the last 10 minutes, but I kind of feel I'm talking to myself right now. So yeah, I'm done actually. Everyone lost attention. Yeah, there's someone. Yay! Yeah? Maybe, yeah? Oh, the question? Yeah, yes.
I just want to ask that here are more or less software guys here, and then how do we contribute to your projects, like or how do beginners to participate in your project?
That's a very good question. So, as I mentioned before, we have this EDA, which is a total construction site. The EDA, the CUHK, because Magic, the tool we use right now, the layout tool for making the chip layouts, is a nightmare to use. It's archaic as shit. It's like 30-year-old code. It's like a lot of Grey Wolf as well, and QRouter. Like, I know QRouter is new, but still, I had to hack around a shit ton of code into it so that it actually did multi-threading. Grey Wolf is like 50 years old, the first code written. Like assert is like obsolete and isn't used anyway. And it did, when I started, I had first to delete like assert the code, remove all the syscalls which execute the binaries from C in the shell. So these tools, you could clean up these tools. Right, you could clean up Grey Wolf, you could clean up QRouter, you could work on Qtflow, you could help Andreas Voss hardware, right? I linked in the slides with his LibreSilicon compiler. That's all code. You don't have to get a clean room suit and run around in the lab. So there's a lot of code thing to do, which I cannot do for time reasons, because in the time we are actually doing research. I'm actually in a clean room suit in the lab, in a clean room, so I cannot write code. So if there is someone who knows either Haskell or C or C++, yeah, I know it's a shitty choice. Maybe some people here like Haskell. I actually can only read this language when I'm stoned. It's functional language. At least it doesn't have as much brackets as Lisp. But yeah, that's something for the guys who like have this functional programming language. How should I say? Like this. I don't know. With Andreas, it's more like a niche for programming for Haskell. But I would say people who like functional programming languages can look into LibreSilicon compiler. It already does some SVG output, so I guess he's on the right track. But it talks a lot about function theory. Usually you recognize usually Haskell developers. I noticed that Congress usually have beards, long ears, and talk all the time about function theory. And you're, aha, you're a Haskell programmer. And monades. Yeah, but yeah, either Qtflow, LSC, Grey Wolf, or QRouter. Please look into the code. Look for Grey Wolf, very important for Grey Wolf. Look into my repo. Otherwise, you have to swallow a little bit thrown up again after looking at the code. I went already through that for you. And yeah, did that answer the question? Okay, great.
briefly show us how do we do that?
Yeah, sure.
Any video or reference that's
video not so much, because all my videos, if you look on YouTube, there is an AC in the background. My laughing sounds totally retarded, so I stopped making videos. But there's of course the GitHub repositories, and I can show you these. Actually, no, what am I doing? I listed them twice. Wait a moment. So, Qt flow is the lowest link. That's the EDA. It's Leviathan CH. Here, that's all the software stuff. Yeah, Graywolf is here. QRoute is here. Yosis is pretty much okay. There's nothing to criticize about Yosis. That's Yosis is awesome. I love it. It can see like modern C programming language, modern dialect, super awesome, nice. Clifford, good job. Clifford, good job. Qt flow, that's my tool, C++, because of Qt5, QRouter, that's in my repositories. I hacked QRouter to do multi-threading, but it's still segfault sometimes, kind of, and it's a pain in the ass to do multi-threaded debugging with GDB. The GNU debugger, well, you can select threads and backtrace. I don't have the time and I don't have the nothing to. And Graywolf also, I cleaned it up a little bit, but look at my code. The original code is terrible. And I mean really, really terrible. So if you like pain when reading code, like really, when you're a code reading masochist, then you can look at the original code. But I went already through that. I've shouted in 3 languages at the whim. I did that for you. That's a clean-up version. QRouter, Graywolf, QRouter multi-threading issues, Graywolf, terrible code. I fixed most of it, look at these repos. I'm looking forward to pull requests. I'm happy about every help we can get. Right now, it's just a few guys in a mumble, 2 guys in a clean room suit. We could use a little bit more speed up in our project and more developers. Especially, I don't give you a bubble now, like developers, but you get the point. We need more developers, and yeah, that's basically all the stuff which isn't scary hardware. These links, they're all software. That's all the EDA and toolchain parts we need. It's also with LibreSilicon EDA tools. Yeah. Okay. Good. More questions? You? Oh, okay. No more questions. What time do we have? I did practice this talk exactly 0 seconds. I think you notice it. If I read Hagen's face expressions correctly, he notices it too. And I have still 3 minutes to be the overly self-critical. Well, yeah, no, I'm done actually. No. Is it here the same as in HKUST that the whole campus is smoking prohibited, or? Anyway, I find out later. Okay, I'm done basically. What is the proper procedure now? Huh? Like, just turn everything off and give the microphone back here. Thanks.
Thank you very much. Well, due to technical reasons, I couldn't show you the QR code for the recruitment of next year's committee. And this is the end of today's conference. I wish you all had a great time. For those who would like to join us as a committee, you could scan the QR code at the registration booth. I'm really sorry that I couldn't show you the QR code due to, I don't know, my notebook's kind of lame. So yeah, wish you all had a great time. Thank you for coming. So yeah, this is the end. Bye bye. Thank you.